Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Stanley number FBB168NRP 5x5 US26D full mortise heavyweight ball bearing non-removable pin steel base hinge in a satin chrome finish. I'll start this video by saying up front I'm a fan of Stanley hinges. I very much am always impressed with their fit and finish, is the bottom line, what I'm stammering over. Their fit and finish is always good. This is an imported hinge. This is manufactured in Asia. Almost all hinge manufacturers, almost all have hinges manufactured outside of the United States. Stanley is one of them. But it's a very good quality hinge. Always very nice smooth action. I've seen how hinges are made, and I can tell you that it is not an easy thing to make hinges. Manufacturing steel doors is an easier endeavor than manufacturing hinges, in my opinion, because I've seen them both done. There's a lot to making a hinge, and Stanley does a good job at it. So this is an FBB168NRP 5x5 26D. Let's dissect the part number. First of all, FBB, the BB portion means ball bearing. With this hinge, there are 5 bearing packets. They're exposed bearing packets, the typical sort of hinge. It also means that it is a 5-knuckle hinge. You can see from the hinge here that it has 5 knuckles. Now on this hinge, the 168, there are 4 bearing packets on that hinge because it's considered a heavyweight hinge, meaning the leaf thickness is heavyweight. On a 5-inch tall hinge, it's 190 thousandths, and my caliper tells me 183 thousandths. Seems to be consistent on both leaves. So it ought to be 190 thousandths. This is measuring 0.183. That means it's heavyweight. If this was a standard weight hinge, 2 things would change. The leaf thickness would go to 140 thousandths, then there would only be 2 bearing packets on the hinge. Wouldn't be 4. This hinge would be quite capable of carrying a very heavy load because of its height, its leaf thickness, and the amount of bearing, the bearing surface area that is working there. So the 168, however, also tells us, it does tell us 5-knuckle, but it also tells us, in addition to being heavyweight, it's made of steel. It's a steel-based hinge. The 5x5, that means that the hinge is 5-inch tall and 5-inch wide. The height is the first dimension on most, not all hinges. Parliament hinges are the opposite. They go width first, but on a full mortise butt hinge, 5-inch by 5, the first 5 is the height. The second 5 is the width in this hinge. Doesn't really matter if you're always dealing with square hinges, not knowing which comes first. But sooner or later, you're going to bump into a 4.5 by 4 or a 4 by 5 or a 5 by 8. And it's really important to know, how tall am I prepping my door and frame? Why is the height the first dimension on hinges? Why is the width the first dimension on doors? Why is the width the first dimension on Parliament hinges? Why is the height the first dimension when it comes to a kick plate? You know, I think it's because you have to have one dimension first, and I think it's likely considered reasonable that the more important of the two would be the first dimension. On a door, what's more important to know, that it's 3 foot wide or that it's 7 foot tall? Yeah, so okay, 7 foot tall, great. Well, I do need to know how wide it is. That's probably more important. That's the thing I want to be told first. On a hinge, the height is more important in my estimation because it will give you an inference as to what the thickness of the door is that you're dealing with. It will lead you to a certain set of possibilities. If I set a 5-inch hinge, you can exclude all of your 1 3/8 doors. If I said 5-inch, you could think 1 3/4 or 2-inch or 2 1/4. So you're able to focus down. The height also is directly related to the capacity of the hinge to carry a load. The taller the hinge, the more capable it is of carrying the door. So it would be considered best practice in the door and frame and hardware industry that if you had doors 3'6" and wider, or you could say wider than 3 foot, they go from 4.5 to 5 inch. And if you have doors that are 16 gauge or heavier, yeah, 5 inch tall, regardless. I'm doing a job right now for a, if you think of the name basically synonymous in our culture with the company that basically comes to a location, picks up cash and takes it somewhere else. They've got a pair of doors going into a facility in the Northeast, and they're 14 gauge hollow metal doors. There's a 3.0 and a 2.0 in a pair of doors. And yeah, we're doing 5 by 4.5 heavyweights. They're just a 3-foot and a 2-foot door, and they won't get used that often, maybe 50 times a day, but you better believe we're doing heavyweight and 5 inch tall because that 14 gauge steel stiffened door. And you could certainly make an argument that continuous hinges would have been the best option, and I would certainly have said that that is absolutely true. They ought to have been full concealed continuous hinges, but that's not what was specified. So butt hinges were specified, and I says, well, if we're going to use butt hinges, we got to go 5 inch tall, and we got to go heavyweight, and that's the way that went. The width is really important too, however, because you need to think about what does that door do when it opens to 90 degrees. Well, that's fine. It doesn't really matter where the vertical axis of pivoting, when all you're really doing is taking that door to 90 degrees. But when you want to get past 90 degrees, you want to make sure that that vertical axis of pivoting is out far enough to get out and around trim, casing, wall condition. We can switch to the screen view, and I can illustrate the concept quickly. Okay, so this is the product that we're looking at here online, and I wanted to illustrate why the width is an important dimension to establish. You know, a lot of, the hinge manufacturer is going to say, to you distributors, we make 4.5 by 4.5 because that's what you want. Doesn't mean 4.5 wide is the right answer to the application. And that's very true. So if we have a frame here and we have our typical, stud construction here, and I don't make a living as a rough framing carpenter. You've got your door. Door is going to swing out. You've got your hinge, your vertical axis of pivoting. Got your leaf. Okay. The door is going to swing out. So the item we're illustrating is the dimension from here. Well, really the dimension from here to here. Okay. This dimension is important as well. That's called the inset. But what we're illustrating here is when you have a condition where your door can literally get to 180 degrees, and just forgive the really poor artistry here. Okay, you get that leaf out. When you don't have a problem in this area with the clearance, then that width is less crucial in the sense that you don't have to think about it to clear something. You don't have to worry about getting out and around something that might be here. However, best practice would tell us that bringing that vertical axis of pivoting as close to the center of the thickness of the door is preferred. So in a case where you have a frame that wraps a wall like we have here, a 5 inch tall hinge would be great, but you know what would be better than a 4.5, or, well, this is a 5 by 5. Let's say that it is 5 by 5 and a 2 1/4 inch thick door. What would be better in this scenario would be to use a 5 by 4.5, or maybe even a 5 by 4. So where this all is dependent on is this scenario as well, which will illustrate our difference. Now we got a 8 inch block wall, okay? And you see where I'm going with this. We've got our hinge. Okay, you want to take that and turn it around and get it out over here. You need to make sure that that door is going to clear this area. So if this was a 5 3/4 frame centered on an 8 inch block wall, A 4.5 hinge is going to get you to 180 degrees. Well, okay, let's say it's a 14-inch existing masonry wall built in 1905 in the northwest area of Chicago, and you're putting in a 5 3/4 frame. And you know that you're going to need to get out to 170 degree because of the requirements of the door opening and a landing behind it. So that's where you got to really calculate what's happening here. And that's where Stanley really comes into their own in the sense of helping us understand, and I'm on the manufacturer's page and clicking on the architectural catalog, or the one that I like to use. There's a formula for wide throw hinges. And knowing the formula, or pardon me, not knowing it, knowing where to find it is the crucial part. So the formula is take your door thickness minus your back set, multiply that by 2, okay, plus your clearance, plus your inset, and that equals your hinge width. Go to the next biggest size. So we could take those basic numbers, and let's say that we were dealing with 2 1/4 minus a 1/4 inch back set times 2. We don't have any clearance, and our inset is, let's say 3/32 of an inch. That would tell me I've done something wrong. That would tell me that I need a hinge that's 3.91 inch. Go to the next biggest size. That would literally be 5 by 4. Okay, but let's say now that I have a clearance issue of 1 inch and an inset of 3/32. I'm sorry, I think I'm running the formula wrong. Plus inset, plus clearance. I apologize. Let's change those values to the correct sign. That application would be, what I had said earlier would need to be a 4.5 inch wide hinge. If we did not have an inset, then we would be okay at a 4 inch wide hinge. So that would be a 5 by 4 or a 5 by 4.5. But if we had a 1 inch inset and we had a 1 inch clearance and a 3/32 inset, now you can see how that changes. Now we need a 5 by 5 hinge, roughly. I wouldn't worry about 9/100ths of an inch. But, I would worry about it if it was a 1/4 inch. If we turn that clearance into 1.25 inches, yeah, it starts to really change on us. So that formula is really crucial in order to determine what is best practice. Because again, you don't want this vertical axis of pivoting any further away from the center of the door than possible. If you're dealing with a 2'8" door that's hollow core, it doesn't matter. You're dealing with a 3.0 14 gauge, 3.070 14 gauge hollow metal door, you better believe it matters. Well, I certainly ran the formula, and 4.5 inch is indeed the correct width for my application for that job that I had mentioned earlier. So keep it as tight as possible and refer to this formula. Let's go back to the product description and go through this extended description. Much of it we've already gone over. It's a 5 by 5 height, 5 by 5 heavyweight, 5-inch height, ball bearing. Now this is a non-removable pin hinge. This is an NRP. We didn't breach that subject just yet. Stanley permanently lubricated non-detachable ball bearings, 190 thousandths. You can drive out the pin for easy removal. Steel-based 5-knuckle. This is a satin chrome hinge. We've got these drawings here. Let's get to the non-removable pin portion of this video, and then we'll continue on. Now, as we move on, considering this Stanley hinge, so this is what you'll see when you're on the outside of the door. Okay. You'll notice this little feature here. You open up the door, you would ultimately gain access to that set screw that's there. Well, that set screw goes into the pin. The pin has a groove in it. Here's your pin, and the set screw sets into that. rendering that pin all but impossible to drive out. I've tried to do it. And without very much destroying the integrity of the frame, damaging the door, your tooling, harming yourself, destroying the hinge, it's not meant to come out. Not that it can't be done. It can be done. Anything can be done with enough time. But that's the purpose of NRP, non-removable pin. The question is always, well, can I remove the pin? Well, sure you can remove the pin. Loosen the set screw, which you can only do when the door is open. You can't get your tool here. You have to have the door open. Loosen the set screw. Then the other part is you can put a pin punch down in there, like a 1/8 of an inch pin punch, and just drive that hinge pin out. One other thing that I like about Stanley is I like their button tips, their tips. You can do decorative tips on Stanley hinges. That's called a button tip. If you just imagine it's a button on your coat. Ball tip would be the most common decorative tip. Steeple, urn, acorn. Other manufacturers have other variants of decorative tips in response to the 2010s movement of manufacturers being capable, able, and willing to accommodate the requests from the marketplace. You know, yeah, your parents had ball tips. You don't want ball tips. You want something else, like a square tip. The point of the matter is, I like Stanley's button tip. That would be the common, the common tip that you would see. Now, we're going to switch back to the screen view where we can take a look at the documents that are loaded below this video. Now, those supporting documents that are down below, tech drawing, installation and template, and hinge size. And let's see what the first document called tech drawing. This is literally a template of the hinge. If you needed to illustrate to someone the dimensional properties of this hinge, you would use this document. We're dealing with a steel hinge, so it's going to be an FBB168, which is right here. Here's our column, and we're dealing with a 5x5. This will work for 5x4, 4.5, 7, and 8 inch wide. I'm sure they can do a 5x6, although it's not listed here. And with those different widths, really what changes is dimension F, which is the edge of the leaf to where the swag or the bend on the hinge leaf occurs, and that's what makes this a full mortise hinge, in fact. We'll also give you the same dimensional properties for all of the other hinges. If this same hinge was non-ferrous, meaning it was made of brass or bronze or stainless, it would become an FBB199. 99 tells us that it's non-ferrous base material, and it is heavyweight, is what it tells us. And a 5-inch tall hinge, it's 190 thousandths, okay, on a heavyweight. The 179, or the FBB 179 or 191, that's a standard weight. I said earlier it was 140 thousandths. I'm clearly incorrect. 146 thousandths on a standard weight 5-inch hinge. Yeah, I would have got that question wrong on the test, so to speak. I thought it was 140 on a standard weight 5-inch. Anyway, moving on, you can see the location of the holes for the screws. This is called a template, but the word template is also meant to refer to the pattern in which the holes are presented. This is the template pattern, and it's a standardized pattern that you can count on when it comes to purchasing doors and frames, etc., or hinges, obviously, from different manufacturers. If the door or the frame or the hinges or all of it is made to the template pattern for the height of the hinge, you can count it always being these dimensional properties. It will always be that. I think you'd have to go to the mid-20th century to find odd patterns. And if you get past 6x6, 8x8 hinges, I would certainly refer to the manufacturer's template, because I don't know that there is a template pattern for an 8x8 hinge. That's a very unusual pattern on a hinge. That would be, let's see, 4B21. Should have an 8x8 hinge here by PBB. That's going to give you some really unusual locations for holes. So I wouldn't take for granted where they were located. That's an 8-inch tall hinge is what you see there. So template document, template pattern as well. The next document that's going to be down below is installation template. This is really just a generic document from National, who is under the umbrella of Stanley. Basically tells you, where to locate the hinges. You probably aren't going to be concerned at all where to locate them, although you might. This client in particular is building a gate. So yeah, this document may be important. 6-inch from the top, 10-inch from the bottom, and then equal those out. And you will find an equal spacing to be a standard in the American door markets, whereas in Europe you'll have 2 hinges soldier stacked at the top and then 1 at the bottom. And what's interesting is if you're on a cruise boat, you'll see doors that way too, and that's because cruise boats are built in Europe. The next document is going to be hinge size. This does not apply to us at all. This is a national document. Now, let's talk, speaking about hinge sizes, let's click on the manufacturer's link here and get back to that catalog, because there is a couple of pages, or a page in particular, in this encyclopedic manual. I refer to it all the time. Maybe in 1990s, where I first learned about, some of the ins and outs of hinges. Stanley's document is very similar to the national document. But here we have hinge height, general hinge information. Okay? We have a column of weight, a column of frequency, door thickness. Okay? So people, myself included, will refer to this often when it comes to hinge selection. What they don't have listed here is the FBB168. They have the concealed bearing, the CB168. And looking at the rating, the weight rating of a 5x5 heavyweight steel-based hinge, 1 3/4 or 2-inch thick door, you will even see it coming out at a low-frequency door up to 600 pounds. I would strongly discourage that. I like to top out on doors hung on hinges at about 150 pounds, maybe 225 pounds when you've got a 5x4.5 heavyweight. But the more you move that vertical axis away from the center of the door, obviously Stanley has tested this material, but that tells me the CB hinge, and our FBB is not listed here, is a more capable hinge. I would personally be not exceeding medium frequency of 225 pounds, in my opinion, of this hinge. Okay, and if you were going bigger than that, I would certainly consider this concealed bearing, because it's in the chart here. Okay, it is important to know that the height of the door determines the quantity of hinges. Doors up to 60-inch will take 2 hinges. For every 30-inch thereafter, add an additional hinge. Okay, so a 7-foot door is more than 30-inch, more than 60-inch, but not more than 90. So 3 hinges. But when you get to 7'6" and above, you'll add a 4th hinge, up to 120-inch, etc. And that's how the logic goes, and you'll equal those spacing out. So this catalog is really helpful, and that's back to that clearance formula that we had before. Okay, so I would, if you have to deal with hinges, I would spend a half an hour and read the first dozen or so pages, the first couple dozen pages of the Stanley catalog. Now, other manufacturers have this same data. I just happen to be partial to the way that Stanley presents it. Okay. Now, the link to the manufacturer's page here, which we've visited a couple of times so far, that is going to allow us to take a look at not only that catalog that we've referred to. That's an old catalog. That catalog's 10 years old. It's just the format that I like to see it in. They've got other variants of the catalog. They've broken parts out. It's not Stanley anymore. It's Dormakaba, who incorporates Stanley and National and Precision. Stanley manufacturer, it does closers and lock sets and exit devices now. I like the good old-fashioned Hinge catalog. You can view not only all the Stanley products that we sell on this page, but those encyclopedic references, new catalogs, old catalogs, a link to the manufacturer's website as well. I have told people unapologetically many times that I really like Stanley products because of their fit and finish. I like how smooth the material works. And it's a good looking hinge at the end of the day as well. What I don't like as much is the fact that I would prefer their flagship hinges to be manufactured in the United States. You know, I would think a heavyweight ball bearing, 5x5 hinge would be considered a flagship hinge where you're not hanging a typical door on it. Let's finish up this video on camera. Now, in the Stanley packaging, one nice thing about Stanley is they have a nice petite logo. I do want the logo on my hinge. I just don't want it to be huge corporate advertising. Stanley got the memo. It's nice, it's elegant, it's petite, it's there, but doesn't overwhelm the hinge. They will send screws, naturally. These hinges come packaged with these hinges in particular are all wood and all machine screws. Do not assume that they're going to send the proper quantity of screws for your application. Best practice, proper specifying of your hinge, would be to tell us the hinge type, the size, the finish, and the screw deployment that you want. This hinge could easily, if this was 5x4.5, I'm thinking it's going to be a hollow metal door and frame, which would mean I want all machine screws. Most likely, not necessarily. Well, you could be that person and then call here on a Saturday and you've got oil rubbed bronze, solid bronze base material hinges, and they came with all machine screws and only half wood screws, and you've got a wood door and a wood frame. That's no good. It's not easy to get those screws. Specify in the comment field when you're ordering to make sure that you get the right screws that you need. There's no reason to get screws that you don't need. The wood screws are number 12 by 1.25 inches, threaded to the head. What I would call a sheet metal screw. Well, it's a wood screw. That thread's a little bit looser. Phillips drive. Those machine screws are 12/24 flat. These are flat undercut head. That feature has an undercut down here, but it's 12/24. Stanley does a nice job, and they include shims with your hardware. You need to be able to take the door and tip it or put it, or cant it in or out, whatever. Bring it this way a little bit, bring it this way a little bit, whatever. They include some shims. Now, if you're doing a fire-rated door, and this hinge can absolutely be used on a fire-rated door, it is a product that has a listing on file with the testing agency that says that this is good to go on a fire door. You ought not, do not use cardboard shims on a fire-rated door. And as the joke goes, if you're going to use something other than steel shims, if you're going to use cardboard, use your competitor's business card. All kidding aside, use steel shims on a fire-rated door. That's actually required. That is specified in the NFPA 80 standard, and of course would be picked up if that's mentioned in your local building code. It would become part of building code. I like Stanley a lot. I would not hesitate to consider you using their hinges. I would not hesitate to use them myself personally. I do wish that material is manufactured in the United States. Having said that, we will conclude this video. If you have any questions on the FBB168NRP 26D, and of course you can do it in all the common finishes, your brasses, your bronze, your chromes, oil rubbed, prime coat certainly. They may be able to oblige special finishes like black. I don't know. I would stop short in saying that Stanley is late to the party of offering powder-coated black and white and other finishes where other manufacturers have moved quite clearly in that direction. But they do entertain custom finishes, and I have gotten finishes that were not listed. Maybe antique nickel, possibly. It's plating, so if they can plate it on steel, I'm sure that they can plate a couple of dozen different finishes. Any questions on this or any other Stanley product, please feel free to reach out to us. And thank you.